Today we are going to be solving a mystery, and we are going to use a person's STR profile to do so. If you remember, we have learned about these already. Each person has regions with repeated DNA sequences, the lengths of which differ between individuals. Don't forget, too, that they are inherited from your parents. Read through the beginning of the homework carefully to understand. I will show you now how to interpret the printout. The gray bar is going to tell us the name or location of the region where the STR is found. For example, D8S 1179. The peak right here is going to tell us that they found the STR there, and under each bar there should be two peaks or two boxes. Now, if we look at these boxes, we see two boxes and two numbers. We're going to ignore the bottom numbers right now in each box. The top number, however, is the number of repeats that were found. We can see, for example, that D8S 1179 for the boyfriend is homozygous because both peaks are on top of each other, and they both have 11 repeats. However, if we look over to this one here, we see that CSF1PO appears to be heterozygous because one has 10 repeats and the other has 12 repeats. Here is an indication of the sex chromosomes that were present. One box has an X and the other has a Y right here. Now, this indicates that it is a male. Now, if it were a female STR, then both of these would be X's. When they do an STR that is exclusively for the Y chromosome, you'll only find one box per STR because there's only one chromosome that is being tested. This is the STR frequency table, and this shows the frequency of that particular length STR in the U.S. population. This table can be used to figure out the probability of having the same profile as someone else. So in other words, how likely are you to convict the wrong person because their STR profile is identical to the real perpetrator? So using the frequencies, you'll be asked to fill in this table for each STR. We can walk through the first example. So, let's see. We're going to do STR19S433 right here. All right, so the frequency of having 13 repeats, which we got that out of the printout, 13 repeats of the allele, we'll go across here, is going to be 0.25. And then the frequency of having 14 repeats of the allele is going to be 0.36. So using the Hardy-Weinberg probability of being heterozygous 2pq, we can find that the frequency of having the combination of 13 and 14 repeats is going to be 0.18. Once you have completed the whole table and have gone through this process for each STR, you will need to multiply all of the last column right here and multiply all of that together to get the overall probability of having this exact STR profile.